Permutations question 13. 7 horses, A, B, C, D, E, F and G, take part in a race. Assume no dead heats. So that means that no 2 horses or 3 horses come in the same place or in at the same time. And also assume that all horses finish the race. Question 1. In how many different orders can they finish the race? Question 2. If A wins, how many orders are possible? Question 3. If A wins and B comes last, how many different orders are possible? And question 4. In how many ways can the first 4 horses come in? So when we hear the phrase how many, we want to think multiply. So we've 7 horses and we want to know in how many different orders can they finish the race. So I have 7 boxes. The first box represents the first place. The second box represents second place, and so on down as far as the last box represents seventh place. I also have multiplication symbols in between each of the boxes because we were asked how many. So for the first place, we have a choice of 7 horses, A, B, C, D, E, F, or G. So we have 7 choices for first place. Once one of the horses comes in first place, so let's say it happened to be horse D, we then have 6 horses left for second place. Once the first and second horse have finished the race, we then have a choice of 5 horses left for third place, because 7 take away 2 leaves us with 5. In the same way, after the first, second and third horse have finished the race, we then have 4 horses left to choose from for fourth place. And in the same way, once the first, second, third and fourth horse have finished the race, we then have 3 horses left to choose from for fifth place, because 7 take away 4 leaves us with 3 horses. And in the same way, once the first, second, third, fourth and fifth horse have finished the race, we then have 2 horses left to choose from for sixth place, because 7 take away 5 leaves us with 2. And in the same way, once the first, second, third, fourth, fifth and sixth horse have finished the race, there's only 1 horse left to choose from for the 7th and final place. And 7 times 6 times 5 times 4 times 3 times 2 times 1 is 7 factorial, which is 5,040 different orders. So how many different orders can the horses, finish the race? They can do it in 5,040 different orders. Part 2. If A wins, how many orders are possible? So if A must come in first place, there's only 1 A of all the horses, so we've only 1 choice for first place. If A has come in first place, then we have 1, 2, 3, 4, 5, 6 horses left to choose from for second place. Once first and second place have finished the race, we then have 7 take away 2, which leaves us with 5 horses left to choose from for third place. And once the first, second and third horse have finished the race, we then have 7 take away 3, which leaves us with 4 horses to choose from for fourth place. And once we have the first, second, third and fourth horse finish the race, we then have 7 take away 4, which leaves us with 3 horses to choose from for fifth place. And once the first, second, third, fourth and fifth horse have finished the race, we then have 7 take away 5, which leaves us with 2 horses to choose from for sixth place. And once first, second, third, fourth, fifth and sixth place is filled, we have 7 take away 6, which leaves us with 1 horse left to choose from for seventh place. And 1 times 6 times 5 times 4 times 3 times 2 times 1 gives us 720 orders that are possible if A is to win. Question 3. If A wins and B comes last, how many different orders are possible? So again, I have my 7 boxes representing first place, second place, third place, up as far as seventh place. So if A is to win, A must come first. So that's why I have A underneath first place. And if B is to come last, B must be in seventh place. That's why I have a B underneath the 7th box. So if A is to win, we have a look at our letters. There's only 1 A, so we've only 1 choice for the first box for first place. And in the same way, if we want B to come last, so we want B to be in 7th place. There's only one B in our list, so we've only one choice for 7th place. So once A is in 1st place and B is in last place, that leaves us 1, 2, 3, 4, 5 horses left to choose from for 2nd place. Once 1st, 2nd and 7th place have been filled, we have 7, take away 3, which leaves us with 4 horses to choose from for 3rd place. And once 1st, 2nd, 3rd and 7th place have been filled, 7, take away 4, leaves us with 3 horses to choose from for 4th place. And once 1st, 2nd, 3rd, 4th and 7th place has been filled, so that's 1, 2, 3, 4, 5 horses. That's 7, take away 5, leaves us with 2 horses to choose from for 5th place. And once 1st, 2nd, 3rd, 4th, 5th and 7th place have been filled, that's 1, 2, 3, 4, 5, 6 horses have their places. Now 7, take away 6, leaves us with 1 horse to choose from for 6th place. And 1 times 5 times 4 times 3 times 2 times 1 times 1 gives us 120 orders. So there's 120 ways we can arrange the horses so that A wins and B comes last. Question 4. In how many ways can the first 4 horses come in? So now I've only got 4 boxes. The first box represents 1st place, the second box represents 2nd place, the third box represents 3rd place, the 4th box represents 4th place. I've only 4 boxes because we're only interested in how many ways the first 4 horses can come in. So I have 1, 2, 3, 4, 5, 6, 7 horses to choose from for 1st place. So 7, take away 1, so we've got 1 horse already in its place. 7, take away 1 leaves us with 6 horses to choose from for 2nd place. Now we have 1st place and 2nd place chosen. So 7, take away 2, leaves us with 5 horses to choose from for 3rd place. And after the 1st, 2nd and 3rd horse have finished the race, 7, take away 3, leaves us with 4 horses to choose from for 4th place. The question said in how many ways, so in here how many we think multiply. So 7 multiplied by 6 multiplied by 5 multiplied by 4 gives us 840 ways. So there are 840 ways that the first 4 horses can come in. Permutations question 14. Karen has to study 7 subjects for her Christmas exams: Maths, French, Irish, CSP, English, History and Geography. She decides to study 4 of these subjects on a particular day. Find the number of different orders in which she can study her 4 subjects. Question 1, if there are no restrictions. Question 2, if she must start with maths. Question 3, if she must not start with maths. Question 4, if she must start with a language. And question 5, if she must not start with a language. So she studies 7 subjects. On a particular day, she wants to revise 4 of them. And we are asked to find the number of different orders in which she can study her 4 subjects. So this is another way to say how many, so we think multiply. So question 1 says if there's no restrictions. So she's studying 4 subjects on this particular day, so I have 4 boxes. The first box represents the first subject, the second box represents the second subject, and so on down as far as the 4th box represents the 4th subject. So there's no restrictions in question 1, so she has 7 subjects to choose from for the first subject. So once she has chosen that subject, whatever it is, for example, it could be French, she's used one of those subjects, and 7 take away 1 leaves us with 6 subjects to choose from for the second subject, because she's not going to study the same subject twice. In the same way, once she's chosen her first and second subject, 7 take away 2 leaves us with 5 subjects for her to choose from for her third subject. And once she's chosen her first, second and third subjects, she then has 7 take away 3, which leaves us with 4 subjects to choose from for her 4th and final subject. And 7 by 6 by 5 by 4 gives us 840 ways she can choose her 4 subjects. Question 2. Find the number of different orders in which she can study her 4 subjects if she must start with maths. So again, I have my 4 boxes representing the 4 subjects with multiplication symbols in between. But this time I have maths underneath the first subject, because we want to work out how many orders she can study her 4 subjects if she starts with maths. So, of the 7 subjects, we can see there's only maths listed once, so she's only one choice for her first subject. So once she's chosen maths, she has French, Irish, CSP, English, History and Geography left to choose from for the second subject. That makes up 6 subjects to choose from for the second subject. And once she's chosen her first and second subjects, she then has 7, take away 2, which leaves us with 5 subjects to choose from for her third subject. And once she's chosen her first, second and third subject, she has 7, take away 3, leaves us with 4 subjects to choose from for her fourth subject. And 1 times 6 times 5 times 4 gives us 140 ways she can choose her 4 subjects if she must start with maths. Question 3. Find the number of different orders in which she can study her 4 subjects if she must not start with maths. So in part 1, we worked out there was 840 ways she could order her subjects in total with no restrictions. In part 2, we worked out there was 120 ways, 120 different orders that she could have her 4 subjects if she did start with maths. So 840 minus 120 leaves us 720 ways, 720 different orders she can study her 4 subjects if she cannot start with maths. So this is a quick way to work it out, but there is another way of doing it, which is longer, using our box method. So again, I have my 4 boxes, which represent the 4 subjects. And underneath the first box, which represents the first subject, I've written not maths. So we want to figure out how many orders where she does not start with maths. So if she doesn't start with maths, she has 1, 2, 3, 4, 5, 6 subjects to choose from for the first subject. So the restrictions only said she could not start with maths. So she could have maths in her second, third or fourth subject. But once she's chosen her first subject, that's 1 subject chosen out of 7. 7, take away 1, leaves us with 6 subjects to choose from for the second subject. Once she's chosen her first and second subject, she has 7, take away 2, leaves us with 5 subjects to choose from for the third subject. And once she's chosen her first, second and third subject, that's 3 subjects, we have 7, take away 3, leaves us with 4 subjects to choose from for the fourth and final subject. And 6 by 6 by 5 by 4, again, gives 720 ways. Question 4. If she must start with a language. So I've highlighted in yellow the 3 languages, French, Irish and English. So she must start with a language, so the first subject must be a language. That's why I have language written underneath. So we have 3 subjects to choose from for the first subject, if it must be a language. Once she's chosen one of the languages, let's say it's French, then 7, take away 1, leaves us with 6 subjects to choose from for the second subject. When she's chosen her first and second subject, 7, take away 2, leaves us with 5 subjects to choose from for the third subject. And once she's chosen her first, second and third subjects, we have 7, take away 3, leaves us with 4 subjects to choose from for the fourth and final subject. And 3 times 6 times 5 times 4 gives us 360 ways if she must start with a language. And question 5, how many different orders can she study her 4 subjects if she must not start with a language? So in part 1, we worked out there was 840 ways she could arrange her 4 subjects with no restrictions. In part 4, we worked out there was 360 ways she could arrange her 4 subjects if she did start with a language. So 840 take away 360 is 480 ways that she can arrange her 4 subjects if she must not start with a language. A longer way to work it out is to again have our 4 boxes for our 4 subjects with multiplication symbols in between. If the first subject must not be a language, well, I've highlighted in yellow the subjects that are not languages, so maths, CSP, history, geography. So we have 4 choices for the first subject if it's not to be a language. Once she's chosen her first subject, let's say it's history, that would leave us with 7, take away 1, gives us 6 subjects to choose from for the second subject. When she's chosen her first and second subject, 7, take away 2, leaves us with 5 to choose from for the third subject. And when she's chosen her first, second and third subject, 7, take away 3, leaves us with 4 subjects to choose from for the fourth and final subject. And 4 times 6 times 5 times 4 again gives us 480 ways.